Welcome to another Desmos video. This video goes along with Module 9 of Math 300, and we're going to be looking at using the normal distribution again to solve probabilities. This time we're going to be looking at finding the probability that a sample mean has a particular value or that a sample proportion has a particular value. So let's look at this first problem, number 16. This is from section 8.1. So we have a simple random sample of size 36. We have a population that has a mean of 64 and standard deviation of 18. So in order to answer this question, we're going to use our friend, the normal distribution. So we can go ahead and type in normal distribution. And we're given a mean and a standard deviation, so we're not going to use the default for the standard normal, the default of a mean of 0 and a standard deviation of 1. We're going to adjust the mean and the standard deviation. So if the population mean is 64, that's the same mean that the distribution of sample means would have. So we're going to go ahead and type in 64. But now remember, for the standard deviation, we're not going to use 18. That's the standard deviation of the population, but the standard deviation of the sampling distribution of sample means is going to be that standard deviation divided by the square root of the sample size. So over here, I'm going to type in the standard deviation of 18, the slash, or you can also type the division sign down here. And then to get the square root, I can either hit this button here. The other alternative is if you type SQRT, it will, whoops, I got two of them. It will type out a square root symbol for you as well. And then in there, I'm going to put the sample size, 36. Whoops, still have two of them. Let's get rid of the second one. Okay. And then if we want to see that normal distribution, we can take a look. There it is. So now we can answer questions like, what's the probability that a sample of size 36 has a mean that's less than 62.6? So to answer these questions, I'm going to click on this button here. And for this one, I want the probability that the sample mean is less than a particular value. That's going to be a left region. And then I'm going to go ahead and put 62.6 here. And we see that the probability the sample mean is less than 62.6 is going to be 3.3204 if we keep 4 decimal places. To do part C, that would be the other side. We want a right side greater than or equal to, so we're just going to click right and put 68.7 to answer that question. Whoops, didn't. Try that again. 68.7, you can see the probability that we have a sample mean of greater than 68.7 is 0.0586 with 4 decimal places. And then this would be one of those inner means, or inner regions. So I'm going to click inner, and then on the left, I'm going to put that lower bound of 59.8. On the right, I want the upper bound of 65.9. This tells me the probability that I draw a sample of size 36 from this population, and I end up with a mean between 59.8 and 65.9 is 0.65. Well, if we round it to 4 decimal places, we're going to get 0.656. We can also look at something that is a little more meaningful here in this problem number 20. So for this problem, very similar problem, but now we're associating it with some real world data. So these are upper leg lengths of 20 to 29-year-old males. And so we have a reference here that from 1999 to 2002 said that the mean length was 43.7 with a standard deviation of 4.2. So for this one, to work these problems, I'm going to change my mean now to 43.7. And I'm going to change my standard deviation to 4.2 in the numerator. And then in the denominator, let's see what our sample size is. For question A, we don't need a sample size, right? So this is kind of a good chance to see make sure you're reading these properly. So question A says, what's the probability that a randomly selected single 20 to 29-year-old male, not a group of them, not a group of a particular size, but just a single or just one male in that age range has an upper leg length of less than 40. So that's going to be a left. We want less than or equal to 40. And you can see pretty good chances that someone has, whoops, I put 49, 40. There we go. Yeah, that makes a little more sense, right? So the mean is here at 43.7. So less than 40 would be a probability of 0.1892. Now that's going to look different than the probability that a random sample of 9 males has an average, right? So this is going to change, and now I'm going to change this by doing that division symbol or hitting the slash key, and then either hitting the square root or typing SQRT, or you might just remember that the square root of 9 is 3. You can also put that in there. So here's my distribution, and now look at the probability is much lower now, isn't it? Because now we're not interested in a single individual having a leg of this size, less than 40, but we're looking at an entire sample of 9 people. And in part 4, if I change this to 12 people in my sample, what do you think is going to happen to that probability? It's going to get even smaller, isn't it? So when you're doing these, make sure that if it's for an individual from the population, we just use the standard deviation here. And if it's a sample, and we're interested in what's the probability that sample has a particular mean, then we have to divide by the square root of the sample size. That's the important takeaway for these problems. In 8.2, we're doing something very similar, but now we're dealing with proportions. And so we're going to use this information here. So remember that if I take a sample from a population of a particular size, a sample of a particular size, and I'm interested in the proportion, now the mean of the sampling distribution of proportions is just going to be whatever the proportion is for the population, same as the mean up here was the same as the mean for the population. And then the standard deviation, we're using this formula. So population proportion times 1 minus population proportion divided by sample size, and then we take the square root of all of that. So when we look at a problem like number 12, I have a sample of size 200 from a population of 25,000, and the proportion for that population is 0.65. So that's going to be the mean of my sampling distribution. So right here, I'm going to put the 65. Now, what is going to be my standard deviation? Well, I'm going to calculate that. Whoops, I put 65, which should be 0.65. Okay. So the mean of my sampling distribution, or sorry, the standard deviation of my sampling distribution, let's get rid of this. And I need that square root again. And then I need a numerator and a denominator. So I'm going to hit that slash key. In my numerator, I have that population proportion times 1 minus the population proportion. So you can either do the math in your head or type in 1 minus 0.35, but 1 minus 0.65, which is 0.35. And then for our first example, or no, for all of them, we're using a sample size of 200. So we're going to put 200 here. Okay. And so now we can see the sampling distribution is going to look like this. Here's our mean, 0.65. And then you can see we have a nice normal distribution. Now for a problem like question B, what's the probability of getting 136 or more individuals with this characteristic? Well, in our sample of 200, getting 136 would give me 136 over 200 or 0.68. So 136 or more corresponds to a proportion of greater than or equal to 0.68. So I'm going to change this to a right-sided question, and then I'm going to put 0.68 here. So you can see this gives me the area to the right of 0.68 And you see the probability of getting a sample where we have 0.68 or more is going to be 0.1869 with 4 decimal places. And then we can do all of the other things. We can look at getting a proportion less than a certain amount, or we can also look at an area in between 2 bounds or outside of 2 bounds. So all of those same things that we can do. That's all we have for today. Thanks for watching. Please do reach out to either me or your own instructor if you have any questions.